Welcome to another program, Consciousness and Science. And today here we are with a very dear friend, Massimiliano Sassoli de Bianchi, and he was one of the speakers in our first International Congress of Potentiality, Consciousness Science. And Massimiliano received a PhD in physics from the Federal Institute of Technology in Lausanne, in Switzerland. His research activities are focused on the foundations of physics, quantum theory, and consciousness, and he's currently the director of Laboratory of Basic Self-Research, and the editor of the journal Auto-Ricerca. And thank you for coming, for joining us here.
Hi Wagner, thank you for having me.
And thank you for your very good contribution to our Congress. And I would like to start exactly there. I was there very happy watching your presentation, and I learned something new that I didn't know, the idea of quantum cognition. And I suppose that was the core of your idea there. Could you explain to us a little bit better about that?
Yes, quantum cognition. So first of all, cognition, quantum, these two words put together. So we have to understand in what sense cognition and quantum mechanics can be brought together in a meaningful way. And quantum cognition, let me just clarify from the beginning, it's not about theories of a quantum brain, for instance. Quantum cognition is really something quite new, by the way. It's a field of research who started, let's say, 15 years ago. And this field of research started because of the fact that psychologists, experimental psychologists, were collecting a lot of data about how we humans think, how we humans take decisions, how we humans react to different contexts. And by collecting these data, we started to have a certain number of problems, not being able to find models, mathematical models, which were able to fit these data. So cognitive psychologists were somehow in the same situation as physicists in the beginning of last century, when were they facing data that were not possible to fit according to classical physics, for instance.
Like a deterministic
Yes,
approach.
exactly. So in this case, of course, this data, the cognitive scientists were trying to fit this data using, for instance, classical probability theories, and even extension of classical probability theory, like fuzzy theories, and so. But even in that, with this variation, they were not able to explain the structure of all these data. So at a certain moment, a certain number of guys had the idea, well, maybe quantum mechanics, which is, has been invented to describe a completely different ambit of our reality, could be the structure that we need to, to modelize this data. So guys like Diederik Ertz and others, tried to use the quantum formalism, really the quantum mathematics, and see if it's the suitable language to modelize the way, for instance, humans take decisions, the way we humans attach meaning to concepts, the way concepts they combine. Because there are similarities indeed in the way concepts are combined and the way meaning can emerge in this way, in a highly contextual way. And also in quantum physics, we have, quantum physics is a theory which had to deal with contextuality a lot, because the experimental context was, changing the property of the system, the observed system, and so there is a high contextuality in quantum mechanics, and that's why this formalism seems to be so good in describing human cognition. So this field now, it's quite developed, but what is interesting as a physicist, for instance, is not only, okay, it's interesting, but I can use quantum mechanics also to do some mathematical psychology, but it is also interesting because you can also say, well, but if it is true that the quantum mathematics works so well in describing conceptual human entity, well, could it be and this was Diederik Hertz, which for the first time, stated this very bold hypothesis. Could it be that the quantum entities like electrons, protons, atoms could be conceptual entities? So this is a dramatic change of perspective, and a very interesting one, but of course a very delicate one. We need really to understand what we mean when we say that, for instance, an electron would be a conceptual entity. We are not saying by this that it is a human concept. But what is interesting is that it seems that we are discovering now that in fact the microscopic layer of our reality, in fact, the best way we have to describe how it behaves, well, this is conceptuality.
So like them having the same nature.
Yes, so what we call usually interaction in physics at the quantum level, it looks much more like a language. Interactions driven by meaning, so connections which are associated to a kind of meaning. In this case, is a known human meaning. Now, there is, of course, big differences with human cognition, because human cognition somehow is a little bit less structured. Well, the quantum layer is very much structured. That's why we have such a specific formalism, So it's probably a much more ancient domain of our reality. So this is very interesting because it opens, different perspective of investigation, not only for the physical reality, but also for understanding better reality as a whole. Because it is possible that this conceptuality view, in fact, maybe this is somehow the way reality has been constructed. The basic language is a sort of conceptual language. So in fact, there would be more mind-like structure, language interactions within reality. But again, let us not, produce too hasty generalization or anthropomorphism, kind of thinking. These are minds of a very different nature. These are languages of very different natures.
That we are trying to discover, in fact.
Exactly.
So we need different notations and syntaxes and
exactly. So think, for instance, the quantum mathematics, which has been invented precisely to start understanding this language. But what is interesting is that we are discovering that the way of being of the quantum entities is very similar to the way of being of the human concept. And that's why they would share this conceptual nature.
And I remember I saw there in your presentation an example, very interesting, when one researcher asked some people about their choice of the representative of the fruit and of the vegetable, and then when you put that in a space, and then you get a pattern of interference, like if it were two waves interacting.
Yeah. So what is interesting is that when you start collecting data from experimental psychology, when now you, as a physicist, what researchers are doing now is trying to create experimental situation, very special one, in order to really study the structure which is behind. So interference, yes, we have a lot of that, but we can even use concept to violate Bell's inequalities. So we have the equivalent of entanglement, which is this connection through meaning.
Interesting.
We have even, a field effect, Bose-Einstein statistics, all kind of things emerges from the analysis of the way how we think. So the full quantum structure is present in the way we human thinks. So we really have, let's say, what we understand now is that humans have a sort of two layers, two ways of thinking. One is the logical, rational one, the one we are used to. But then we are discovering that there is also a very important layer of our thinking process, which is conceptual. We call this conceptual. Sometimes it was believed it was more irrational, but in fact it has it is highly structured, and the quantum mathematics, the full quantum formalism appears to be needed to fully describe these structures. So, of course, these are quite difficult topics, by the
Yeah,
way.
of course.
And what is interesting is that today psychologists, well, mathematical psychologists, experimental psychology are learning quantum physics, and they are becoming, by the way, very good at this. And I would even say, since they come into this game with no prejudgment, you know, no big school of thoughts from the past, and they are so interested in understanding how what quantum physics, how it works, that today they are probably starting to make even discovery that are attracting the interest of physicists, because, you know, it's a new domain of investigation of a quantum-like nature.
And then, Massimiliano, where the consciousness would fit in this model? Consciousness, sometimes people say as a common, big, whole, collective consciousness, or sometimes our individual consciousness, the out-of-body experience. How do you see this in terms of the multidimensionality?
Yes, well, let's say in this language, which is, by the way, also the language of quantum mechanics, so the consciousness manifests itself, well, let's say, not directly, but you have, you know, quantum physics is a physics of potentiality. So every time you speak in terms of potentiality, of course you have to think about, okay, this potentiality at some moment are actualized. So we are describing a physics where the process of actualization of potential properties is, you know, is the basic process. So every time you have an actualization of potential properties, there is something which, of course, is producing this process. So it can be a context, some physical context can trigger this process of actualization of potential properties. But I would say the consciousness can also be understood as one of the contexts in which are able to bring potentiality into actuality. So it, you know, it fits consciousness, and you can bring it into the game as an element which allows you to understand this process of the actualization of potential properties. Because, you know, it's really the element of the agent. So even in a cognitive experiment, you know, a person will have to take a decision. And this decision, many times, is totally unpredictable. It produces an actualization of potential properties, so there is a process of creation, and then you start seeing the consciousness as this element which is producing these creative processes, and which are, by the way, irreducible. So of course, now you can place the consciousness at different levels, and I would say that this ancient problem of mind, body, or consciousness, but well, you know, it's very difficult, because of course you have so many structures. So at a certain moment you will say, well, maybe this element, this context is the consciousness, but maybe it's another one or another one, so you probably never solve that. But I would say it's interesting in the sense that we can have a language that can help us to describe maybe not the consciousness itself in the sense of the being consciousness, but the manifestation of the consciousness and the different way it can manifest. So that's where you can try now to even expand more these theories and try to say, okay, maybe there are possibilities, you know, conceptual entities that we are not yet considering, and that are also playing a role in the description of reality. And maybe this language will allow us to describe this possibility in a better way.
It is interesting that many times when people discuss about consciousness, and in our field, conscientiology, as you know, we talk about consciential energy, we say that one of the properties of the consciousness through consciential energy is to lower the entropy of the systems.
Yes.
How does this process of lowering entropy, syntropy, negentropy, whatever, fits in this point of view?
Yes. It's important to lower, let's put it like this, there's not a joke, but it's important to lower the entropy, but not too much.
Yes.
So sometimes this is something that maybe we forget to say. Because, you know, if you have too much entropy, this is, you know, a disorder. It's like a gas, for instance.
Yes.
So you cannot have no information there.
About individual pairs,
totally random, no structure. But now if you lower the entropy too much, then again you have no any more information. Everything is perfectly ordered, so you have no complexity again.
Yeah.
So let us not forget that life is a very complex process, and this complex process, by the way, it's not about lowering entropy, but it's about optimizing, finding this optimum between having some entropy and reducing it, but not too much. So it's a living system. It's a system which lives at the edge of the chaos sometimes. So it's an open system, and always finding a compromise between lowering entropy but not too much. So because the problem is complexity. And my opinion is that in fact the consciousness is precisely manifesting by creating complexities, and it does so at different levels of our reality. Our body is a very complex system, and we can use it to manifest the consciousness. And maybe I think we have other vehicle of manifestation of the consciousness, but these vehicles are complex systems. And what we really do as consciousness is to create this complexity. And so this complexity is not really about creating too much order. It's about creating interesting structures.
Otherwise, you lose the dynamics, the interactions. Everything stops. In fact, if it gets too much organized, and the final state.
Exactly. Imagine if you want to record information in a crystal, and it's impossible because everything is the same. So if you have a quasi-crystal, which is not so ordered, well, maybe. Schrödinger, for instance, before the discovery of DNA, was thinking that we should have quasi-crystal inside our body where, to store information to be stored. And this quasi-crystal, in fact, we then later on discovered was the DNA. But this is not a perfectly ordered structure, because we need a language again, and the language needs some complexity, some variety, and so some disorder, not only order,
Very good, but I'm forced just to create a pause here. We go to our break, and then we return with Massimiliano to discuss more about consciousness and physics. So then, returning here to our second block of the program, Consciousness and Science, and we were discussing here physics, quantum mechanics, and consciousness with our friend Massimiliano Sassoli de Bianchi. And I would like to bring a question here to you just to see if this can poke more of the discussion here. We discussed before in some of the opportunities we had about the Big Bang, and then you said that you have a different vision interpretation of the Big Bang compared to the regular, perhaps with most of the people. How do you see the role of consciousness or consciousnesses in this whole thing of the Big Bang, like the fine-tuning of some of those basic constants, variables that made life possible and things like this?
Well, that's a huge question.
I'm
not sure I'm not sure I can say something very intelligent about this kind of thing, because, of course, in fact, on many of these issues, we don't really know a lot. So the Big Bang, of course, is a good scientific hypothesis. It has a lot of data supporting it. So I'm not against at all the idea of a Big Bang. Let us just remind that maybe there are also some data that are pointing to the fact that maybe Big Bang is a sort of description of an evolution of our universe, but we have, for instance, objects in the cosmos which maybe are too ancient to be compatible sometimes with this description. So there are some anomalies which also may point out to the fact that the Big Bang is not the whole picture. But now, personally, for instance, when I think in the terms of Big Bang, the first things I'm pointing to is, okay, but here we are thinking in a way which is, let's say, a little bit updated. In which sense? Let me explain. The idea here is that the universe is created, and when we think of the universe here, we are thinking as if space and time would be a sort of container of the universe. So we are here starting from a perspective where reality would be contained in a theater, which is the space-time theater. So this is a very ancient way, because today we know that things are quite different in the sense that space, the idea is that it is space and time are contained within something huger, which is reality. So, and not the other way around. Why I'm saying this? I mean, it's just, you know, a little philosophy. I'm saying, oh, you know, it's not, it's the other way around. It's, you know, no, it is because when you really investigate reality, let's say as a physicist, first of all, as a physicist, I may say, okay, what is a modern physicist doing which is different from a classical ancient physicist? Well, physicists in the past were studying entities, quite conventional entities like this one, you know, very similar to our physical body. So we have not to forget that we have dealing with this kind of entities, what we call the macroscopic entity, since pre-cultural time, pre-scientific time. So we have somehow, you know, inhabiting a very special place of our reality, the surface of this planet. And we had to somehow find a way to represent these very special entities, the object, the macroscopic object, and the very special kind of relation they have. So this network of relations somehow was represented by the construction of what we call the Euclidean space. So we see now this Euclidean space, if we look at it in that way, it has some element of construction, of conventionality. You know, we have focus on very specific entities and very specific relations. And now, since we have completely forgotten about this construction, we started to think that reality is contained in that representation. But now a physicist investigating deeply reality in contexts which are very different from the ordinary one. Because in a quantum laboratory, you create conditions which are extremely sophisticated. You ask questions of a very non-ordinary kind. And when you do this in an operational way, you create situations, but you don't find outside there. For instance, you will take a lot of care to shield the laboratory from, let's say, the bombardment of heat or things like that.
Rays
or whatever, to have a very controlled ambit. And now when we have done that, we have discovered properties of a very different kind, relations of a very different kind. Now, when we tried in the beginning to say, okay, but let's try now to take this relation, this property, try to fit them into the spatial theater. We were unable to do that. And that's why quantum entities are so puzzling and so on. So the point is that all these new entities, these new properties, new relations that we have discovered in these non-ordinary ambits do not fit the spatial theater. So we really see that, for instance, a quantum entity really cannot be fully represented in this theater. So when we speak about the Big Bang, we are assuming, as from the beginning, that everything is contained in the space and time theater, you know, which is, I would say, a very wrong starting point. And you may even think that the big problem, for instance, we have in bringing together general relativity and quantum mechanics, it's because the starting point is so different and so incompatible. And we are taking a very parochial point of view as a universal one. So space is just a theater within reality, and reality is something much, much bigger, and physics is already telling us this. But physicists are also humans, and they like space, and they like to
attach to some concepts.
And so, for instance, with other colleagues, we are somehow trying to promote this idea of non-spatiality, because a physicist generally will have a tendency to speak in terms of non-locality. But you see already the term non-locality, it remains without, you know, it's still spatial. It's no local in space, but it's still, you know, in the spatial representation. Absolutely. So you have the idea it's somehow everywhere in space, but you're still inside. You know, it's like a Plato caves. We are not willing, for many have some difficulty in leaving this cave. But in fact, and that's interesting, we need more than a single theater to represent reality. The Euclidean theater is just one among the many theaters we can construct. And very recently, by the way, we proposed a new notion, we call it the Multiplex Realism, precisely to bring the idea that we have these different theaters in a reality which is highly multidimensional and cannot necessarily, be brought into a same simple representation like the space-time one, but then you have the quantum theaters, then you have the relativity theaters, and so on. And by the way, not necessarily you will find a unique theater for everything, because also
Absolutely.
this theory of everything is also a kind of prejudgment, preconception. Maybe reality is structured in a way, but each time you try to represent part of it, you have to do it, but you will have a partial representation. And other sector of reality needs different theaters, and you can try to find some elements of the different theaters, but these are all will remain partial morphism. You will just find a part of the structure, but not the full representation. So you see...
Absolutely. And I was going to ask you this, it was planned already, but you just mentioned, we're mentioning multidimensionality.
Yes.
So we have this concept in conscientiology, as you know, the possibility of us leaving the body and going to different levels, structures, realms of reality. And it seems there are many. But would this be the same concept, for instance, of the multiverse people have? Because sometimes we see the multiverse as being many physical universes, perhaps with some different charge of the electron, different constant gravitation, and things like this. Or this would be structured like in the sense of the things we see in projections.
Well, by the way, in physics there are many different kind of multiverse theories. Yes. So depending from the context, the way you will deal with the notion of many different universes will change. For instance, you have many worlds interpretation of quantum mechanics. Sometimes they call this the parallel universes, which is...
Everything that could happen
happens somewhere
Yes.
in the multiverse.
Yes.
This I don't like. Even some very intelligent people are somehow giving credit to this interpretation. From my viewpoint, is a little bit naive, but it also it doesn't take, let's say, what we know seriously enough. For instance, in quantum physics, you have the Schrödinger equation, which tells you about how systems evolve in a very specific context. But you also have the so-called projection postulate. It tells you what happens during the so-called collapse of a wave function. This is another, process of change. So, for instance, people considering the multiverse as in many words interpretation, they just think that this process of collapse of a wave function is simply non-existent. They simply say, okay, I eliminate the problem of understanding this process. But this process is precisely the most interesting one. So we are really, eliminating the all interest, because this is the process of actualization of potential properties. This is the process which has a lot of richness, and which is, by the way, also the process that today is not considered in theories of evolution, even in the neo-Darwinian sense. As in Darwinian theory, just process of change where only selection is operated only at the level of what is already actual. But they are not considering, for instance, the actualization of potentiality, which we know in physics, these are important processes of change. So now, coming back to your question, the majority of these approaches where you consider multiverses also consider that these different universes are not communicating, or almost not communicating. Whereas we know from experience of out-of-body experiences and similar experiences that in fact we can enter this other existential dimension.
Yes.
So communication is possible, so there is a language, there is a way somehow to relate to these other realities, these other theaters, these other, we can use many terms here, of course, to describe. So they are connected at some level. So the idea of the multiverse, I would say it's not the correct one
I see.
It is real. So, and we don't, by the way, let's put it like this, also many times this idea of introducing many universe is again a way not to change the paradigm of reality containing space, you know. So in order not to abandon the idea that everything is in space, I just replicate and I do many spaces. But when I do many spaces, in fact, I'm not introducing a more interesting structure. I'm just, you know, doing a sort of cloning the same structure many times. So somehow I'm losing the entire richness of, you know, this reality, which is structured at a very much more complex level, which is what we call potentiality in quantum mechanics. But this, you know, it's like these different potentialities, you know, they are telling us about something which is really existent in reality. So,
in a deeper level
on a
of
deeper
reality.
level, yes. So we need just to accept, again, that there is more than what we can observe in this particular theater, this very specific theater, which is the three-dimensional one. We have to accept that as intra-physical being, of course, our viewpoint from here will be limited, of course, because we can just, you know, find the traces of these entities, which for the most of their time belongs to, you know, different theaters of reality.
Yes.
So, of course, this will be somehow the problem. But we can find strategies, you know, to explore these other theaters. One is to use in a very precise way our cognitive abilities, our intellect. Others are also by, you know, exploring what is the reach we have as consciousness, because maybe we consciousness, and this is an hypothesis, of course, I also acknowledge, we are able to escape from this Euclidean theater.
Yes.
And okay, this it happens to be the case, and it's very interesting. So we have inside of us a potentiality which extends beyond this theater, and this is what we do probably when we explore these other existential dimensions.
Very good, very good. But again, Massimiliano, we needed to stop for a bit just to end this block. And please stay with us, we are going to come back. So then we come to our third block of the program, Consciousness and Science, again with Massimiliano Sassoli de Bianchi. He was here with us at IAC campus during our first International Congress of Potentiality, Consciousness, Science. And then I would like just to ask you a few other things. I know they are very complicated questions, nobody knows, but it's just to poke our discussion here. Yeah? Do you think the Big Bang created only the physical universe, or also the extra physical realms, dimensions we can visit during our out-of-body experiences? I know, as I said, nobody knows that. But sometimes I get the impression that, well, the Big Bang was only a physical thing. You know, other dimensions pre-existed, if even we can use time again, you know, coming to our conditionings. But do you have any ideas, even if it is just philosophical, about that?
Well, I must say again, the answer I would like to say, I don't know.
That's the only good one, yes.
I really don't know. But if I have to say, even at this level, it would be very intuitive. I see no reason to connect the Big Bang. In fact, I have, personally, have some difficulties, you know, in seeing the Big Bang as the beginning of even our physical reality, even in the conventional sense of the terms. Because again, you know, the very notion of an explosion, you know, for instance, the space and times are created, but are created where? Within reality again. So why should I separate, you know, in this very artificial way, also this physical, conventional, three-dimensional reality with these other realities? Because in fact, they are present in a certain sense altogether. So it's like just like we are focusing on a process, and then since we think that this process is the only thing which is real, then we start somehow to give it too much reality or too much importance. You know, again, is it because I'm thinking inside the box of space, inside of the box of space-time? So no. I don't think so, and I think that we need to find, you know, more advanced way to reflect about what it means to have, what becoming means, you know, because again, many times we are stuck into the idea, or maybe things, you know, time does not exist. Yes, but we have evolution.
Yes.
So again, you see
cause and effect.
Yes. So there are processes of change, but these processes of change are not necessarily related with the time variable which is used in classical and relativity theory. So here we have to understand, but we have somehow to upgrade our understanding of what change means, and again, think out of the box, of a very classical box of space or space-time. So quantum physics is introducing interesting aspect in that element, because of course the way certain change happens, you know, again, the notion of actualization of potential properties, we have to think about new way of understanding that. You know, the idea, for instance, that we live in a spatial temporal reality does not mean that change cannot happen. But these are quite sophisticated topics, because, of course, they require a lot of care, you know, because, by the way, our language is full of temporal concepts. And when we try now to think what it means, so what I do, for instance, many times, I prefer to say that we have to use, let's say, non-ordinary notion of times, or, you know.
Yes.
But this is difficult topics also for physicists. When they try to describe reality as a whole, they try to put time inside this description, but then you obtain a sort of block universe where nothing happens anymore. Yes. So I don't think
some crash back.
Yes. So I don't think these are the correct images. But again, it's very difficult to talk about this kind of thing. So by to answer very straightforwardly to your question, I mean, no, I don't see any reason. I would even think that somehow the more subtle dimension or existential dimension are even there, probably even before the physical one. Or, you know, because somehow I think, you know, we think about matter, for instance. Matter is an important notion in physics. And we have to think about matter as a sort of source of potentiality. But now potentiality needs to be actualized. So matters need to be structured. So matter, you know, this term matter comes from the root is mother. So mother is what supports existence. Yes. But now, of course,
gives birth.
Yes, but you need also the father aspect, you know. So it's a meeting, and this is when, let's say, the dance will start, and you will little by little give shape to matter.
And I was going to ask exactly about this. When we were saying about actualization of potentialities, it reminded me of energy in general.
Yes.
Physical, mechanical, whatever. Potential of work. But also about our subtle energies, prana, chi, orgone, how they would fit in this model. Are they the potentiality or the actualization of a potentiality? And I suppose you saw there my presentation with bioenergy in water, or the egg, and those lights in the functional MRI. The light is just like a mathematical calculation there, but properties changing there.
Yeah.
Any comment on that, Massimiliano?
Yeah, I mean, so the element, the energy, you know, okay, we know matter, and we know that matter always has this attribute of having energy. So we could say, in a certain sense, we could say energy is somehow one element, not only energy, because we could say also momentum or even angular momentum, you know, because, yes, all these dynamical properties, you know, so there are elements in matters which tells us that matter is not totally passive. There is a dynamical aspect, and this is what we would say symbolically the father aspect, the agent, you know, there is something which is acting. Now, the point is, when I'm acting on something, I can use, you know, this action can be mediated. You know, I may push directly this glass with my hands, but I can use this and do it the same way and still have an effect. So I think that our reality is highly structured. So when we talk about subtle energy, I think that these energy are describing matters of a different kind, which are somehow manifesting at a different layer of our reality, but there is a connection. And therefore, in certain very specific context, this connection can be used to produce an effect also, let's say, in our theater, Euclidean theater, and can be observed, for instance, in the very beautiful experiments that you have done. Now, the experiment that you have done, for instance, it was with a magnetic resonance instrument.
Yes.
They are quite intriguing, by the way, because you may ask, one fundamental question would be if these subtle energies, or let's say subtle, I even prefer to call them subtle matters sometimes, yes, just to give to them a more substantial, objectivity, because if they, it's not
they are real. Yes.
And energy, in a certain sense, you just have one kind of energy, but what is important is the different forms of energy are in fact different carriers of energy, And so you have these more subtle carriers, and now you say, okay, usually we don't observe these carriers. We are not used, otherwise everybody would agree that subtle, these phenomena are, as objective as our glass. But what are the location, let's say, where they can more effectively act on ordinary matter, for instance? So this, and what is intriguing in your experiment is the fact that the magnetic resonance works on spin observables.
Exactly.
Now, spin observables are the only observable, quantum mechanical observable, with having no correspondence with classical physics. Because, in classical physics you have energy, momentum, angular momentum, all this, and you have the, physical quantity, and the corresponding observable in quantum mechanics. But now you don't have anything like a spin in classical physics. So spin is the purest element of a quantum element, which is really not, nothing to do with classical physics. So if one would say, okay, this is the most, let's say, non-ordinary new element of reality that we have discovered by means of quantum physics. So one would say, okay, it's intriguing because maybe these spins are really the mechanisms that are it's more easy to use to affect, ordinary matter by means of this more subtle matter. So it's a
could be the bridge.
Yeah, sort of a privileged entrance, But it could be just a chance. Maybe the same kind of experiment you have done could work also on machine working on different principles. So this, I would say, it's like maybe just a coincidence or just, an association of idea for the time being. But it's intriguing and interesting, So I, as a physicist, I keep this in mind.
Yes, of course.
Because, by the way, just coming back to our previous discussion, we usually think about spins as as rotations, because the name itself says that. But in fact, and that we have been working on that very recently also with Diederik Hertz. We published a paper. Well, it's not yet published, but and the title of the article is "Do Spins Have Directions?" And in fact,
yes, because they show spins pointing up
yes, but
and down.
in fact,
integer 1.5.
Yeah, but the fact is that we cannot associate any spatial direction to spins.
Yeah.
They are not in space. These are direction outside of space. We need a bigger space to represent the direction of spins, and that's what we prove.
Yes.
So these are, very simple entities, like little arrows in a certain way. We think about them in terms of rotation, but in fact,
it's a concept.
When we try to represent this direction inside our three-dimensional space, it's impossible, and we really need an ample theater to do that. Yes. And then, so again, they are totally outside the Plato's cave, but of course they have some little correspondence. Sometimes you can find traces of this direction inside our space, but you cannot fully represent them. So it's interesting. So you see how I think what is interesting, and the notion I like here to explore and develop also in my research, is understanding better what this non-spatiality means, you know. And so, and I think it's a very important paradigm also for the future investigation of the manifestation of the consciousness beyond the physical body, because we really need new models to think about this possibility, because otherwise it's very difficult, first of all, to do research, but also to communicate something, because we have many phenomena, but we need to try a little by little to find models that are sufficiently credible, you know, also to attract the interest of more researchers on these topics, you know, and because if you are not able to find out some good mechanism, some good description and explanation, or possible explanation, even speculative, but nevertheless intelligent enough, and which can also relate to all the things we already know, you know, because good explanations are also explanations that are in connection with the other explanation that we already have. Yes. So, and I think this conceptuality interpretation of quantum physics is promising also in this direction. But let me emphasize, it's very speculative already for quantum mechanics.
Now the beginning.
So here's, of course, for the scientific community at large, these are highly speculative explanations.
Perfect.
Not the phenomena. The phenomena we can have them.
The modeling.
But the interpretation of the phenomena, this of course requires also the challenge of finding the good explanation as well. And this is what science is all about, finding the good explanation.
Let me bring another thing that we will try to find a good explanation here. What we call in conscientiality the auric coupling. Two people connecting via aura, consciential energies. And in the process of this many times, people get the sympathetic assimilation of others. Could we call that a kind of entanglement of a macroscopic big system, entanglement of people?
I think yes. I think the term entanglement, by the way, is not, I mean, it's used specifically in quantum physics, but let me tell you maybe in a very simple way, what is entanglement? Well, entanglement is nothing but connection. So when you say auric coupling, it means that by certain means you are establishing a connection which will produce some meaningful correlation.
Yes.
Now, so in a certain way, the notion of auric coupling is very simple. It's just, you know, connecting two different entities in a way that they can exchange information. So why now why entanglement is more mysterious than just connection? Well, for a very simple reason, that this connection in quantum physics, for instance, do not happen inside of space. These are non-spatial connections.
So this was Einstein's spooky
action at a distance.
He made a joke out of it.
Yes, but you see how problematic it is, the fact that two systems remained, connected. Let's say they appears to be spatially separated, but not experimentally separated. So Einstein was puzzled by the fact, there is spatial separation, and then if there is spatial separation, then there has to be also experimental separation, which means if I act on one system, it does not have to have effect on the others.
Couldn't be faster than the speed of light.
Yes, okay. But the point is, no, spatial separation is not enough to separate two entities, because these two entities are not present only inside of our space, but they are present in a huger reality. And it is precisely outside the Euclidean space that the entanglement connection happens. So now when you have this multidimensional vision, in a certain way, entanglement becomes a much easier to understand notion. It's simply establishing connection, but non-ordinary one, because simply you don't see them, you see. So the same thing happens when we do some auric coupling. Of course, maybe a clairvoyant person will have a way of visualizing this connection in some well represented, but we will have some, we'll see maybe some energy connecting
some colors and lights.
Yeah, so you will see that these entities are not fully separated and they have some bridge somehow. But for a person who cannot see this happening, he will see two spatially separated entities, and magically, interacting as if they were connected,
Let me ask you something that might have some relation with that. I suppose you know that I study also a little bit, as much as possible, ectoplasm.
Yes.
The old 19th century, beginning of 20th century seances, all those manifestations, because I saw, perceived, even produced some of this sometimes. And I was trying to study this, and I came across to something interesting that shares some of the same characteristics of the ectoplasm. That is the Bose-Einstein condensates.
Yeah.
What is your opinion about ectoplasm? Do you have any kind of working model explanation, even if it is not based on hard data? We are here freely philosophizing. What do you think of ectoplasm? A different level of organization of matter? How sometimes the ectoplasm can come from a person's body, so it's organic, and then that can shape a glass or a metal thing. So different elements, if you think of a number of protons there. Any idea on that?
Yeah, it's of course it's here really we need a new kind of physics as now, because so how can we extend our understanding of physics? For instance, ectoplasm is a process of materialization. So now in physics, usually we can transform energy into, well, one should not say matter, because it would not be completely correct, into mass.
Particles,
into mass. Now, and that's why energy and mass are two equivalent concepts in physics today. And we have not to mix mass with matter, which is something different. But so energy and mass somehow, so it's just a different way of manifesting the same energy into a mass, something more concrete. So this we know, but we know also that we need a certain experimental condition which are very specific to produce this materialization. We do this, for instance, in physics laboratory. You go to the LIC, or
the particle accelerator.
Particles are created all the time, just by means of kinetic energy. And so, of course, this happens. We know that. Now, I think ectoplasmic production, or even when in this very special case it appears that ectoplasms can transform to something very similar to ordinary matter, or really ordinary matter, then I think these processes are different and are really, a description of new processes that we have not yet studied as physicists. Mm-hmm. So again, what is the good language to try to express this possibility? It's very difficult to answer. Personally, I think that the model I was talking at the Congress, by the way, the idea that reality would be much more conceptual than we think. So the physical entities, not only the physical one what we are used, but even the more subtle one would be a conceptual entity. This introduces an element of explanation, possible element, because conceptual entity can manifest at different degrees of abstractness and concreteness. So, this ectoplasmic manifestation could be processes where precisely this change of state from more abstract to more concrete happens in a very particular way. But we have really, for the time being, all this is not quantitative, it's just a new language. Is this new language not only helping us to understand better the physics that we already know, but also this paraphysics that we are just, beginning to scratch a little bit, we don't have real theories for this. It's purely phenomenological for the time being. Yes. I would say we are really at the same level, even not maybe at the same level of Democritus when he was, thinking about maybe atoms exist.
Indivisible parts of matter.
But so we are really at that level, really at not beginners, but even before that. Yeah. So we have to be very prudent and very modest. Yeah. Doing a lot of experimental research, yes. Let us not forget that ideas and models, in any case, have always been driven by data. We, even think about quantum mechanics. I mean, quantum mechanics is an amazing revolution, but it didn't happen because some guy all of a sudden started to think that, let me write a Schrödinger equation, or let me postulate a projection. Postulate, no. It's because some experimental data was in need of an explanation. And then more people start to accumulate more data, and then more minds start to think about, how can I understand that? So this will trigger new ideas, new models, and new hypotheses to be tested. To as a physicist, I must say, I don't have a theory. I hope, but maybe I hope to live a certain amount of years still to be to be able to bring some new elements in this game of understanding these more subtle realities, this consciential extra-physical reality, which, to my opinion, are perfectly objective and needs somehow to be better studied, better modelized.
That's why you used the expression, I think was, what, multi-materialism?
Yes, exactly.
Because matters in different levels of organization, subtlety.
Exactly. I think that physicists are, are materialists, and I am in that sense a materialist, but not a naive one. So a naive materialist would be a guy thinking that matter has, we already know what it is, but the notion of matter has evolved. Now today we understand matter in a way that previous physicists would have said this is not anymore matter. So I always think that what is manifest, exists in a manifest way, needs some support for that. And this support is matter. Now, how many kinds of matter do we have? Physicists are already exploring this. They know about many different kinds of matters.
Yeah.
Think about dark matter, for instance.
Dark matter.
Which, by the way, is interesting how it happens that we have a sort of matter today, but we know about its existence.
Yeah. I already thought if, for instance, psychosoma could be made of
I don't know, but certainly
the WIMPs.
For instance, in the conceptuality interpretation of quantum mechanics, an hypothesis is that dark matter is a part of our reality which has not co-evolved with the other kind of matters.
So it remained like the ancient way.
If you have not developed a language, so interaction is driven by meaning, and even the quantum entity and the measuring, the macroscopic, the entities, they have co-evolved. It's like a mind and the language. This evolves together, and that's why they can connect through meaning. Now, it's very possible that dark matter is an aspect of our reality which has remained separated in the sense that it has not co-evolved with the rest, and that's why we cannot interact with that. But gravitation would, in that case, play a different role with respect to the other physical interaction, because, of course, we know about dark matter because of the gravitational effects.
Galaxies, yes.
And this also tells us that maybe gravitation has to be dealt with in a completely different way with respect to the other forces that we know, and that maybe it's very difficult and maybe impossible to try to obtain a model where gravitation would play the same role as the other physical interaction.
Strong, weak force,
and that's why we are struggling so much, because this would be completely a different kind of interaction.
Well, we have very, very, very little time now, but I would like to bring a last question here again, just giving some space to our imagination. Do you think that the LHC Large Hadron Collider that at CERN just discovered the Higgs boson, do you think some of their discoveries could help us understanding some of these deeper multidimensional realities? I know it's guessing.
No, personally I don't think so. I think they will do some great physics, probably, a very special kind of physics, high energy physics. There's a lot of resources on this kind of experiment. I understand why. I'm not, as a physicist, I think we are giving too much resources to this way, this investigation in this sector of reality, which is now becoming very specific, this high energy. So there is a certain way of understanding physics which is, promoting these kind of experiments. But I think that it's also it would be more interesting, for instance, to study also more simple systems and solid matters, for instance, solid state physics and other ambits, where maybe more resources would be welcome to promote, because maybe we don't have to reach these high energies to really discover something new. So it could be an impasse, So let us not forget also that a lot of this research comes from previous military ideas, it's nuclear energy, and that's why, historically it receives so much finite grants and so on. So it's not necessarily only because the most interesting physics would be there. But of course, this is my personal opinion, and many of my colleagues would completely disagree, and this is okay. But I think that the most interesting discovery will come by trying to understand better, more simple systems. And for instance, quantum mechanics, you know, try to understand also the very, you know, in fact, I think there are a lot of questions that we have not yet resolved, you know, very simple question. We were talking, what is a spin, you know, what is how it happens, coming back to relativity theory, how it happens that the speed of light is the same for any inertial observer. You know, people take this as granted. Well, it's
but why?
Why? How can you really explain? Can we really explain things like that? So I think that there are a number of things that needs to be clarified at a very foundational level, and that somehow today we have advanced a lot, like in technology, you know, but now physicists will have also a little bit probably to stop, and they need to come a little bit back to basic, because I have the idea that we lost a few pieces, you know, behind, and that if we don't get back these pieces, we will not be able to continue this amazing construction we are trying to do. And probably these pieces, this is my educated guess, could help also to better understand better the more subtle reality that the consciousness can manifest when in expanded state of consciousness, like out-of-body experiences and so on, which again, I think needs to attract more authentic interest from the community of scientists.
Very good. Well, Massimiliano, it's a pity we don't have more time. We could be here for hours and hours, but perhaps next time.
Okay.
Thank you very much for coming, not only to this interview, but also to our Congress. You certainly enriched everything here. Thank you
very much, Wagner, for having me.
Thank you.
Bye-bye.
And again, thank you for being with us. And we will come back next time with another interesting person to be interviewed here in our program, Consciousness and Science.